we have the same setup as last time, right? Same numbers, just different placement. The 15 is no longer next to the 21, it's opposite the 21. So we are going to set up and solve the angle C first. So here's our ratio. Sine of C over 10 is equal to the sine of 21 over 15 this time. Okay, so we can set up our ratio here. The sine of C is equal to, and I'm just going to multiply both sides by 10. So I get my ratio here, sine of 21 times 10 divided by 15. I'm going to put a decimal in there so it gives me my answer in decimal form. So I have 0.024 approximately. And in order to solve the angle, anytime you're finding an angle, you take the inverse sine of whatever that ratio is. Oops. There you go. Okay. So again, just review this. You set up your ratio. Sine of C over 10 is equal to the sine of 21 over 15. Multiply both sides by 10 to isolate. Try.
Why do you use the inverse sign?
Anytime, because what you're told here in this step right here is that the sine ratio for angle C is 0.024. So if you want to know what angle C is, you take the inverse function of that. So it's kind of like saying if this had been cosine of C equals 0.024, you take the inverse cosine of that ratio to find what the angle measure is. Okay. So when we take the inverse sine of this, the inverse sine, and we can just, again, access that exact value, we get an angle measure of 1.4 approximately. Okay, now, is that consistent with what you would expect? Should your angle be smaller than 21 degrees? Yeah, so again, as of right now, that is still consistent. Okay, so if this angle is 1.4 and this angle is 21, what we can do is we can add that to 21. That gives us the value that we could then subtract from 180. So if we take 180 minus that value, we get this angle to be 157.6. And now again, we could confirm this. 157.6 plus 1.4 is 159, plus 21 is 180. Messing. Did I put... Oh, this one. I see. Thank you. Let me... let me redo from this step. It didn't register my 10. All right, so sine of 21 times 10, all divided by 15. Okay, so you should get 0.24 approximately. Now we can take the inverse sine of that. Thank you. Okay, and so you get 13.8 as your angle. All right, so if we take the inverse sine of that ratio, we get 13.8, which again, it confirms we're looking for the angle measure that's smaller than 21 degrees. Okay, and so now if we add this to 21 and then subtract that from 180, we get our angle up here to be 145.2. And again, if you add those together, confirm that you get 180. Those do confirm that. Okay, so here are your different possibilities. The last thing we need to do is solve for B. So we can set up our ratios, again, using law of sines. B over the sine of the angle opposite that is equal to the known ones. So here, 15 over the sine of 21. And if we calculate this, we take 15 divided by the sine of 21, or actually, I'll go 15 times the sine of 145. Again, I'm going to use the exact value. And then divide by the sine of 21. Hit enter. I get my side to be 23.9 approximately. Okay. Now, is that consistent again with what you would expect? It's the largest side opposite the largest angle. The sum of the two smaller sides is greater than the longest side, so it is consistent with what you would expect. And now, is there a second triangle that can be created here? Okay. Now, in order for that second triangle to be created, it would have to be this one that's highlighted in a dashed line, correct? Okay. Now, if this side is 15, that means this side is also going to be 15. And now think about it. Will this triangle exist, the dashed one? Can anybody explain why it's impossible for this dashed triangle to exist? Like,
because the largest side is an opposite the largest angle.
good. In this triangle right here, this would have to be an obtuse angle, correct? If it's the supplement of 13.8. Is it possible for an obtuse angle to be opposite a side of 10 when an acute angle is opposite a side of 15? No. So it's inconsistent in this case. So in this particular case, there's one and only one triangle. And so SSA can work, but it's not guaranteed to work. And the way that SSA gives you one single triangle is if the side opposite the given angle is larger than the other side. Okay, so in this information right here, two sides and an angle. Okay, if the side opposite the known angle, okay, is larger than the other one, and again, assuming this known angle is an acute angle, okay, you are only going to have the one triangle. If in the ASA or AAS, you're going to use the law of sines, and there's only one possible solution. When you're using SSA, you are going to use the law of sines as well, but there's two possibilities here. There's a possibility of one solution and a possibility of two solutions. Okay, when we looked at the cases here, the different cases are with our angle, our known sides. If we have a longer side and a shorter side. If the shorter side is opposite our angle, then it's possible to create this second triangle, correct? So if the shorter side is opposite that known acute angle, then you're dealing with a triangle where you have two possible solutions. If our longer side is opposite the given angle, is it possible to hinge this, circle it around, and intersect within this triangle? No, it's not going to contain a triangle. It'll extend beyond. It would be moved down somewhere like this. Okay, so if your longer side is opposite the given acute angle, then you have one solution using SSA and law of sines. If the opposite side is the shorter one, then you have two possible solutions.